Hello, my name is Donnie, and last time we looked at the scatter plots, its patterns, correlationship, and the least squares regression lines. Today we are going to continue exploring the scatter plots. We will explore the residual plots and influential points and how to transform the equation to make it into a linear pattern. So first of all, what is a residual plot? Literally, it's a plot. It displays the difference between a predicted value and the actual value. We use residual plots to see how far away the actual data is from the predicted value. The regression line shows the pattern the data form, but it doesn't show the actual value of the data, just a close prediction. So by the predicted value, we're talking about the value of the regression line. This is an example of how a residual plot looks like. There's a regression line and the dots are the actual values. The difference in y-axis is the difference between the predicted and actual numbers. Influential points. We saw previously about the outliers, the values that are abnormally larger or smaller compared to the majority of the data. Influential points share a similar concept. It is basically an outlier whose removal would greatly impact the regression line. In this diagram, we see two sets of data and its regression lines. The difference between left and right is that there is a point on the right bottom, the outlier, missing in the right graph. You can see how the outlier has greatly impacted the shape of the regression line. As we have removed the two outliers on the right bottom side in the left graph, the regression line on the right graph has greatly tilted towards more to the left side, and it is more angular. In this case, we can call the outlier as an influential point. In this case, we can see that the red dot is an outlier, way above the pattern. We see how its removal does not influence the regression line that much. In this case, we only regard the red dot as the outlier, but not an influential point, making the regression line into a linear pattern. When we plot the data and it shows the following shapes above, it is obvious that the regression lines will look like either exponential, reciprocal, or a log regression line. For simplicity and higher rate of r-squared value, we sometimes transform the following regression lines into a linear form. So what we do is that we transform the equation and make the regression line turn into a linear line. So in order to shift the regression line into a linear pattern, we need to change the shape of the equation into something like y equals ax plus b. So how do we do that? Let me show you an example. Here we have a set of data where the 10, 20, 30, 40, 50 are the x, and the y's are 200, 250, 340, 510, and 770. As you can see here, it shows kind of like an exponential regression line, and also the regression line pattern also here shows that it is. So first of all, what we have to do is that we have to change this into a log value. Here we have exactly the same value, and either Excel or Google Sheet, what you do is you press equals log 10. You need to change it to log base 10 for a much simpler way of doing this. And then you click this, click enter, and here you have the log. So now we have our log value. And what you have to do here is simple. Just press this until the very end, and then you got all the log y values. And for simplicity, we don't want that many decimals, so I'm gonna round it up until the 100th place. And here you have all the log y values. You copy paste this and you make a new set with exactly the same x values. And here you can see that we have a much more linear pattern, and also the r-squared value is 0.96, which means that it is highly accurate, or the patterns are quite close to the actual values. This is how you shift a non-linear regression line into a linear line. So when you see an actual pattern of something like a polynomial or exponential, you gotta do a logarithm. In any other situations where you have, for example, a radical, all you have to do, just remember, is change the equation into ax plus b. You just gotta manipulate the equation and the numbers to change it into that form, and then you're done. We have found that our new regression line is log y equals 0.015x, I just rounded up to the thousandth place for simplicity, plus 2.12. Now, if we want, we can change this back into the polynomial, no, it's the exponential way again, because regard that this log, we have used the log base 10. So what we do here is quite simple. We change it back to 10 powered by 0.015x plus 2.12 equals y. Now, to make it into a proper equation, we can say that y equals 10 powered by 0.015x plus 2.12. This is another trick when you turn the regression line into a linear pattern, and then you can do this back again. Well, I mean, this just kind of depends on the situations, but it's a trick that you can use quite useful. So that's it for today. Thank you for watching and hope you liked the video. If you did, please subscribe and send any emails if you have any inquiries. Thank you.